Good afternoon, viewers. I am lecturer Arvinder Mami from Government Polytechnic College, Amritsar, and my subject is Industrial Metrology and Statistical Quality Control. And the topic given to me today is measuring instruments. First of all, let me explain uh, metrology. Metrology is nothing but a pure science of measurement. Measurement of what? Measurement of anything. Measurement of length, measurement of weight, measurement of light, measurement of temperature. What we restrict ourselves in our engineering methodology to measurement of length only, and this measurement of length, or you can say linear measurement, is done by some measuring instruments. So, we start with measuring instruments. The basic measuring instrument, as you are seeing on the monitor, is engineer's steel rule. An engineer's steel rule is also known as scale and is a line measuring device. It is a precision measuring instrument and must be treated as such. It works on the basic measuring technique of comparing an unknown length to the one previously calibrated. It consists of strip of hardened steel having line graduations engraved at interval of fraction of standard unit of length. Depending upon the interval at which the graduations are made, the scale can be manufactured in different sizes and styles. The scale is available in 150 millimeters, 300 millimeters, 600 millimeters and 1000 millimeter lengths. Some scales are provided with some attachments and special features to make their use versatile. For example, very small scale may be provided with a handle to use it conveniently. They may be made in folded form so that these can be kept in pocket. Shrink rules are the scales which are used in pattern and foundry workshops, which takes into account the shrinkage of material after cooling. Now, you can see on your monitor a simple sketch of a simple scale is shown. It has two straight edges, this one and second one. On this side we have scale in millimeters and on this side we have scale in inches. This is the simplest most measuring instrument. Now, following are the desirable qualities of a scale which every scale must possess. Number 1, it must be of good quality spring steel so that its life uh, should be lifespan should be more. Secondly, the lines which are engraved on the scale should be very clear so that these lines can be read easily. It should be of reputed make so that it is of, if it is of reputed make, mean up to some extent quality is assured. It is metric on two sides, mean we have two edges, as I have already shown to you, one side we have scale in millimeters and on the other side we have scale in inches. Thickness of the markings or the divisions should be minimum, so that accuracy should be more. Now, in reading this type of scale, some error may occur due to our reading technique. When we are to read a scale about a point, suppose we are to take reading about point A, the eye of the observer should be exactly at 90° to the point of reading. Then and only then reading can be a good reading or can be a exact reading. Otherwise, if eye of the observer is on this side, then corresponding to this point A, observer may take reading from this side, or if eye of the observer is on the left side, then corresponding to A, observer may take reading at this point. So, in reading a scale, an error which is called parallax error get induced. So, while taking reading with the help of scale, eye of the observer should be exactly at 90° to the point of reading. Now, characteristics of a scale or characteristics of a line standard. First characteristic is accurate engraving on the scale can be done, but it is difficult to take full advantage of this accuracy. For example, a steel can be read to about plus minus 0.2 mm of true dimension, or in simple words you can say the maximum accuracy that can be obtained with the help of a simple scale is of the order of plus minus 0.2 mm. Second, it is easier and quicker to use as a scale over a wide range of. And third, the scale markings are not subject to wear, although significant wear on the leading end leads to undersizing. In our scale, there is no built-in datum which would allow easy scale alignment with the axis of measurement. This again leads to undersizing. The scale divisions on the scale start a little bit away from the edge of the engineer's scale. There is some gap is left between the edge and 0 of the scale. So, in this way there is no built-in datum in the scales. Then fifth, scales are subjected to parallax effect, as I have already explained what is parallax effect. So, a source of both positive and negative errors are there. Sixth, for close tolerance length measurement, scales are not convenient to be used until or unless we use these scales in conjunction with microscopes. Then second basic measuring instrument is caliper. Caliper is an instrument used for measuring distance between or over the surfaces, or for comparing dimensions of workpiece with such standards as plug gauges, graduated rules, etc. In modern precision engineering, they are not employed in finishing operations where high accuracy is essential, but in skilled hands they remain extremely useful. No one can prevent the spring of the legs affecting the measurement, and adjustment of the firm joint type can be made only by tapping a leg or the head. Thus, results obtained by using calipers depends largely on the degree to which the user has developed a sense of touch. On the monitor you can see different types of calipers. The a caliper shown against serial number A is for external measurement of the workpiece, and shown on the serial number B, it is for internal measurement of the workpiece. Then shown against the C, serial number C and serial number D, again this type is used for external measurement and this for internal measurement. The difference between first two and the last two is fine adjustment is done with the help of fine adjustment screw, this and this, and in these two cases fine adjustment is done with the help of tapping, and the last one is for measuring the different parameters of on a threaded portion. Then comes the Vernier calipers. The Vernier instruments generally used in workshop and engineering metrology have comparatively low accuracy. The line of measurement of such instruments does not coincide with the line of scale. The accuracy therefore depends upon straightness of the beam and the squareness of the sliding jaw with respect to the beam. To ensure squareness, the sliding jaw must be clamped before taking readings. The zero error must also be taken into account. The instruments are now available with a measuring range up to 1 meter with a scale value of 0.1 mm or 0.2 mm. Here let me tell you what is meant by scale value. Scale value is a distance between two consecutive divisions. If the distance between two consecutive divisions is 1 mm, then scale is called, the scale has scale value 1 mm. If the distance between two consecutive divisions is 0.5 mm, then scale value of the scale is called 0.5 mm scale. These scales are made of alloy steels, hardened and tempered. Hardness is about 58 Rockwell C, and the contact surfaces are lapped finished. In some cases, stainless steel is also used for their manufacturing. Now, Vernier principle. The principle of Vernier is that when two scales or divisions slightly different in sizes are used, the difference between them can be utilized to enhance the accuracy of measurement. In simple scale, we have a simple divisions or a one scale. But in case of Vernier calipers, we have two scales. One is called main scale and another scale which is called a Vernier scale, and these scales are uh, the scale values of these scales are different. Now, we discuss it in detail. First of all, we take the principle of 0.1 mm Vernier. Now, on the figure you can see principle of 0.1 mm. Here the scale is accurately graduated in 1 millimeter steps. We have this is the main scale, and another scale which is on the movable jaw is called Vernier scale. This main scale is in millimeters, mean scale value of the main scale is 1 mm, means the difference between two consecutive divisions is 1 millimeter. So, scale value is 1 millimeter. The main scale is accurately graduated in 1 millimeter steps and terminates in the form of a caliper jaw like this. The second scale, which is movable, it is also fixed to the caliper jaw. The movable scale is equally spaced into 10 equal parts. This scale is divided into 10 equal parts, which are equivalent to 9 divisions on the main scale. Therefore, one division on this scale is equivalent to 9 by 10, that is 0.9 mm. So, scale value of the Vernier scale is 0.9 mm. This means the difference between one graduation on the main scale and one graduation on the sliding or Vernier scale is 0.1 mm, because scale value of main scale is 1 mm and scale value of Vernier scale is 0.9 mm. So, difference between these two mean 1 minus 0.9 is equal to 0.1 mm. Here, if the Vernier caliper is initially closed and then opened, so that first graduation on the sliding scale corresponds to the first graduation on the main scale, a distance equal to 0.1 mm has moved, as you can see it from the figure. First of all, if we close the both jaws of the Vernier caliper, and what we do, the first division on the main scale and first division on the main scale are made to coincide exactly. Then the distance between two jaws, mean fixed jaw and the movable jaw, the distance will be equal to 0.1 mm. This 0.1 mm is called least count of the Vernier caliper. What is meant by least count of the Vernier caliper? Least count mean the difference between one division of the main scale and one division on the Vernier scale, and this least count if this least count is 0.1 mm, what does it mean? Mean the minimum reading we can take with this type of Vernier caliper is 0.1 mm, not less than that. Now, principle of 0.02 mm Vernier. Now, on the figure you can see the principle of a 0.2 mm vernier. Here the upper scale is the main scale and it is in scale value of this main scale is 0.5 mm. Scale value is the distance between two consecutive divisions is called scale value. Here the scale value is scale value of the main scale is 0.5 mm. And here on the vernier scale we have 25 equally spaced divisions which corresponds to 24 divisions on the main scale. The vernier scale has main scale graduations of 0.5 mm, while the vernier scale has 25 graduations equally spaced over 24 main scale graduations, or you can say 12 mm. Hence, each division on the vernier scale is equal to 12 by 25 means 0.48 millimeter. The difference between one division on the main scale and one division on the vernier scale is, this is the scale value of the main scale and this is the scale value of the vernier scale. Difference between these two divisions comes out 0.02 millimeter. So, this is the least count of the vernier caliper. So, with this type of caliper, vernier caliper, the minimum reading up to 0.2 mm can be taken, not less than that. This type of vernier caliper is read as follows. First of all, note the number of millimeters and half millimeters on the main scale that are coincident with the 0 on the vernier. Then find the graduation on the vernier scale that coincide with the graduation on the main scale. This figure must be multiplied by 0.02. 0.02 is least count. So, this figure must be multiplied by 0.02 to give the reading in millimeters. Then obtain the total reading by adding the main scale reading to the vernier scale reading. Suppose this is the actual situation on the vernier caliper. Here 0 of the vernier coincide somewhere here. Here this division is 34th, then half division mean 34.5 mm. Now, we are to see which division of the vernier scale coincide exactly with the main scale. Here this division coincide exactly. This is the 12th division. This 12th division must be multiplied by the least count. 12 multiplied by the least count. Least count is 0.02. So, it comes 0.24. This 0.24 is added to 34.5 mm. So, the total reading comes out to be 34.74 millimeters. Now, types of vernier calipers. According to Indian standard IS 3651 1974, three types of vernier calipers have been specified to make external and internal measurements and are shown in the figure. I will show these figures later on. All the three types are made with one scale on the front of the beam for direct reading. These types are called vernier caliper type A, vernier caliper type B, vernier caliper type C. Now, you can see on the monitor a type A caliper, vernier caliper. Type A vernier has jaws on both sides of the on both sides for external and internal measurement and a blade for depth measurement. The type shown on the monitor is of vernier caliper type A. Here we have two jaws on one side and two jaws on other side. These two jaws are for external measurement and these two jaws are for internal measurement, and we have this blade which is used for depth measurement. Then comes type B. Here we have type B vernier caliper. It, type B is provided with jaws on one side for both external and internal measurement. We have both the jaws on one side. These two jaws are used for internal as well as external measurement. These two faces are used for external measurement and these two faces are used for external measurement. There is no provision for depth measurement in this type B. Then comes type C. Type C has jaws on both sides for making the measurements for marking operations. Here we have again these two jaws for external measurement and these two jaws for these two faces for internal measurement, and these knife edges are for marking purposes. All the parts of the vernier caliper should be of good quality steel and the measuring faces should possess a minimum hardness of 650 Hb. The recommended measuring range of vernier caliper as per IS 3651 1974 are 0 to 125, 0 to 200, 0 to 250, 0 to 300, 0 to 500, 0 to 750, 0 to 1000, then 750 to 1500, 750 to 200 2000 millimeters. Then another linear measurement instrument is micrometer, which is more accurate than simple scale, caliper and vernier calipers. These micrometers are designed on the principle of screw and nut. Figure shows a 0 to 25 millimeters micrometer, which is used for quick accurate measurement to the 2000ths of a millimeter. It consists of following parts: frame, anvil, spindle, thimble, ratchet, lock nut. Now, you can see on the monitor 0 to 25 millimeter micrometer. Here we have frame, this is the fixed anvil, this is the spindle, it is a movable anvil. This portion is called barrel, which acts as a nut. This portion is called thimble and the last portion is called ratchet. Micrometer requires the use of an accurate screw thread as a mean